All right, for today, start by trying your warm up to go through and attempt all the questions. You should be able to answer them. The biggest takeaway from this is that I want you to understand what it means to be a factor of an expression or a number, and fill those out. And we'll talk about those tomorrow. I'm going to start by just a quick activity of really explaining what a greatest common factor is. I'm sure you've heard the phrase before. So, for instance, I'm going to basically write down my name. And I'm just doing this activity right here that you can do. And I'm going to write down another name. Usually I take suggestions in class, so thinking off the top of my head. Let's go with, I'm going to spell this wrong. Mariah Carey. I bet I spelled that wrong. Okay, so let's see what myself and Mariah Carey have in common. So if you look at this, we both have an M. We both have an I. We both have a Y. Both have an E. That's if I spelt it right. And that's it, right? So our GCF is what we have in common, which is MIYE. And then the remaining things is what we don't have in common. So just in general, a GCF is something that you have in common. So if I'm looking at this problem, for instance, okay, where we're actually trying to find the GCF of these terms. When I look at 27 and 72, I need to find, first of all, the biggest number that divides evenly into both of those. My thoughts at first are, well, does 27 go into 72? Because if that's the case, then that's the biggest number that goes into those two. 27 times 2 is 54. 54 plus another 27 is well over the 72. So my next thought is 27 is 9 times 3, and the biggest multiple that I can get from that is 9. So I think 9 might evenly divide into those, which makes sense because 9 times 8 is indeed 72. So my GCF, the number part of it, is going to be 9. Then I'm going to think about the x's and what they have in common. If you think about x squared, that's x times x. And this is x times x times x. So if I'm thinking about this as to what they have in common, they have 2 x's that I can take from both of them. So my GCF here is x squared, right? And then the last thing I'm going to look at is my y's. And I'm going to think about it the same. This one is y times y times y times y. This one is just y times y. If I'm thinking about how many I can pair, I've got one here, one here, one here, one here. That's as many pairs as I have. So this would be y squared. Now what I do to finish this is I'm going to divide each one of these by that. So 27 divided by the 9 is going to give me, so 27 divided by the 9 is going to give me 3. X squared divided by x squared is going to give me 1. You might see here later that that one was kind of unnecessary to write down, but we did it. Y to the 5th divided by y to the 2nd gives me y to the 3rd, right? Because I just say I've got 5 of them. I took 2 away. All right. Then we have our minus. I'm going to go back to my 9, right? And I'm going to divide that into 72, which we said was 8 earlier. X squared, we're dividing into x squared here. So x to the 3rd divided by x squared gives me x. You'll notice that there's also I don't want to circle it because it'll look weird. But you'll notice that there's 1x left here and 3y's left here, just like what we wrote here. Okay. And then y squared divided by y squared just gives me 1 if I want to write that down. You might look at this and say, again, Miss Phi, don't know why we're writing the ones. We're going to get rid of them. So 3 times 1 times y to the third is just 3y. I'm sorry, y cubed minus 8x. And then we have our GCF out front. So this is an example of factoring with a GCF. So you're just trying to find what they have in common, take them out, and then write what's left when you divide that GCF out of it. A quick check is that remember that this is basically reversing the process of multiplying. So if you use your distributive property right now, you should get the exact same thing that we started with when we did this problem. All right, let's take a look over here. So for this one, you'll notice that all of them, as I'm thinking about things they have in common, they all have a negative. That's the first thing I notice. So the first thing I'm going to write as my GCF is a negative. The next thing I notice is that not all of them have an x. There is no x in the third one, so x will not be a part of my GCF. And the last thing I'm looking at is my y's. Okay, this one's only 1y. The most y's I could take out of any of these is 1y, so a negative y is what's going to be my GCF. And I'm going to basically go through and take that negative y out of each one of these. So negative y out of that is going to leave me with x3y to the fifth. A negative y out of the second one is going to leave me with plus 10. I know it's plus now instead of minus because I took the negative out front with the GCF. X to the fourth. No y because the only y that it has I've already pulled out front as a GCF. Plus 9y. Again, how do I know this is correct? Because if I were to multiply or distribute this negative y back out, I should end up with the thing that I started with. All right. So in this one, you guys should already know how to fill these in based on what we talked about with our generic boxes. So as I'm looking at this, I want to fill in a couple things here. So I look at my GCF in order to determine this. So I'm going to go vertically first, and I hate where I put those little parentheses for our final answer, but it'll work. So if I look at this one, I'll put it at the bottom. That's what I'll do. Vertically, x squared and 2x, they have a GCF of x. I'm going to use a different color. It's pretty hard to see on there. There we go, x. And then 3x and 6, the biggest number they have in common is, that I can divide evenly into those, is 3. Going to go horizontal now, so x squared and 3x should have an x. And 2x and 6, the biggest number that divides evenly into those is 2. So x plus 3 and x plus 2 are my two factors. On the next one, we'll go vertically, right? So we'll go looking at that. We'll go with x as our GCF. On this one, negative 6 would be our GCF. Over here, it'd be x. And on the last one, it'd be positive 5. So our two factors are x plus 5, x minus 6. And I want you to start developing a pattern. Hopefully you started seeing a pattern from what you were doing yesterday, but there is a pattern of what the two numbers are that go in these parentheses with these values. Again, let's do it again. So these GCFs are x. These GCFs are negative 9, right? GCFs across are negative. Ooh, no, they're not. GCFs across are x, and GCFs across on the bottom are negative 9. Again, I can check and triple check this being correct because I know not negative 9. Sorry, I've lost my mind. Not negative 9, negative 11. So I know that my, I've got to match up to make sure that these multiply right. So like x times x gives me x squared. X times negative 11 gives me negative x. Negative 11x, negative 9 times X gives me negative 9, and negative 11 times negative 9 gives me a positive 99. So X minus 11 and X minus 9 are my two factors. There is a pattern between the values that are going in the boxes and the values that are coming out. If you'll notice, okay, these two numbers, right? 2 plus 3. What does that add up to? 2 times 3. What does that multiply to? Where do you see those numbers? You should see them. Right? And I can continue on. Let's do it. Let's look at another one. For this one, 5 plus negative 6. That'd be negative 1. 5 times negative 6. That'd be negative 30. And again, where do I see those numbers? Right there, right? You might be like, I don't see that number. I don't see a negative 1. All right, there's a negative 1. All right, and one more time. The numbers negative 9 plus negative 11 and negative 9 times negative 11. That gives me 99 and negative 20, which you can see are the values here again. So, what is the pattern that exists between the trinomials and the numbers of the box? The numbers add together to be the X term and multiply together to be the constant. Okay. So we should be able to use that pattern to kind of speed up our process of thinking. So as I'm looking at this, right, what are two numbers? I got to ask myself the question, what are two numbers that multiply to 12 but add to 7? And those two numbers are 3 and 4. Then you can pull out your GCFs, right? X4, X3. So X plus 4, X plus 3. All right, now we need to think of two numbers that add to 14 but multiply to 40. So 10 and 4 would be those numbers. So I've got X 10 when I pull out my GCFs, X 4 when I pull out my GCFs. So X plus 10, X plus 4. All right, now we need two numbers. It gets a little more difficult when we throw in negatives that add to a negative 5 and multiply to a negative 14. Right, so these are my two values. So it'd be X minus 7, X plus 2. So we're just fast tracking this idea of what we're going through. So we can kind of lose the box now, right? Because when I say box, we mean area model. Okay, so we can lose that because there's a faster pattern. Like I want you to pull out that pattern. So two numbers that multiply to 50 but add to 15. Two numbers that multiply to 30 but add to negative 13. I know they need to be negative because the only way to multiply to a positive and add to a negative is if those are both negative numbers. Okay, we've got multiplying to negative 10, adding to negative 3. The only way to get a negative number when we multiply is if one's negative, one's positive. All right, so continuing on, we're going to look at difference of two squares. Real quick, multiply part 1 out. I don't need to do it. You can do it. You can multiply it with your box method. You can multiply it, or area model. You can multiply it with your generic rectangle for your area model. And then I want you to tell me what all those have in common. Take a minute to do that now. All right, so you should have figured out that these are your values, and that the thing they have in common is they don't have any middle terms. So you don't have an X term or a Z term or an A term. Those middle terms have dropped out because you have opposite pairs. So when you're trying to factor, we can work that out backwards. We can just say, oh, okay, well, that is, if I think about this is x, and I got x squared. This is 5, -5, and I got -25. And the only reason I can do that is because you'll notice that the binomial factors that they're trying to get you to multiply together are exactly the same. Only one has a plus in between the two values and one has a minus in between the two values. So likewise, we can work backwards from that, right? So if x plus, let's write it as a formula kind of. If we have a plus b times a minus b, that's always going to give me a squared minus b squared, which is why we call it difference of squares. It's the difference, the subtraction between two squared objects. So coming over here, right, if I know that my values are, this is a squared, this is b squared, right? Well, that means that a's got to be x, because x times x gives me x squared, and b's got to be 9, right? Because 9 times 9 gives me 81. And again, one's got to be plus, one's got to be minus. Let's keep going. So this one, right? If this is what we're calling a squared, which I know is kind of confusing because you see an a squared, I'm asking myself, what did I multiply by itself to get 49a squared? So this has to be 7 and 7, a and a, right? It's got to be the same thing. Then I've got my minus 4. The only thing that gives me 4 when I multiply it by itself is 2. We need 1 plus, 1 minus. Last one, 100 is going to be 10. 9b squared is going to be 3b. I get minus, plus. And again, that's just another shortcut to get you there faster. Could you build the area model and do your generic rectangle? Yes, but this is kind of a method to get you there a little bit faster. All right, and the last thing I'm going to go over is factoring by grouping. So you'll notice that I've got some cubes in there and some crazy things. But my method is super easy for this stuff. All I have to do when you have 4 terms like this is put them in your box from left to right. I'm taking a minute. Give me a second. Okay. And pull out your GCFs. So on the top, going across, I've got an 8 and an r squared. I'm taking an r squared because this one's got an r squared. This one's got an r cubed, which means I can take an r squared from both of them. On the bottom, they don't have anything in common, so I'm going with a plus 1. Going vertically, right, I've got my r cubed and my r, so I know I can take an r out here. And this one, I've got my -64 and my -8, so I know a -8 can divide evenly into both of those. So my factors are 8r squared plus 1 and r minus 8. I'm going to let you finish the rest of these because they're pretty darn simple. But go through those and then work on the practice of the factoring homework. Hopefully I've cleared up a lot of stuff for you. Feel free to text me as you're working through stuff. I may or may not be able to get to you. It just depends.